Engineering physics. Today our topic is interference due to thin parallel film for reflected system. Consider a ray SA that is coming from a monochromatic source having wavelength lambda. If this ray SA incident on a transparent film having refractive index nu and the thickness of the film will be T. The ray incident on the upper surface of the film, some part of the ray gets reflected along AB and some part of the ray gets refracted along AC. As you can see in the diagram, this is angle of incident, this is angle of refraction, and this we drawn a normal. Now we have to find the path difference. For path difference, our formula is nu, that is refractive index of the film, in bracket AC plus CD minus AL. Here you can see AC plus CD minus AL. Now we have to find the values of AC, CD and AL. To find the value of AC and CD, we have to go in the triangle ACN for finding the value of AC, and for finding the value of CD we have to go in the triangle C and D. As you can see here, in triangle ACN we take the cos R, that is refractive angle. Cos R is base upon hypotenuse, that is CN, that is thickness of the film, and hypotenuse AC. By putting the value of CN, we get the value of AC equals to T upon cos R. Mark the equation 2. In the same way, we can find the value of CD by going in this triangle CND, taking the value of cos R, CN upon CD. CN is the thickness, and in this way we can find the value of CD equals to T upon cos R. Mark the equation 3. Now we have to find the value AC plus CD. Here we put the value AC and the value of CD. That will become 2T cos R. Mark the equation 4. Now we have to find out the value of AL. For finding the value of AL, we have to go in the triangle ALD. We have to take the sin I, that is perpendicular, that is AL, and base, that is AN plus ND. We took AN plus ND because here N is dividing it. As you can see here in triangle ADL, sin I equals to AL plus AN plus CD. Here we find the value of AL equals to AN plus ND sin I. Now we have to find the value of AN and ND. For that we have to again go in the triangle ANC and CND. For that we have to take the tan R, that is perpendicular upon base, that is AN plus upon CN. CN is our thickness, that is, here you can see in triangle ANC, tan R equals to AN upon CN, and CN is the thickness, that is T. So we find out the value of AN equals to T tan R. Mark the equation 6. In the same way we can find the value of triangle value of ND by going in this triangle D and C. CN perpendicular and base is ND. Here we can find out the value ND equals to T tan R. Mark the equation 7. After substituting the equations 6 and 7 in the equation 5, here in place of AN and ND we get the equation 8, that is 2T tan R into sin I equals to AL. Here we find the value of AC plus CN, equation 4, and value of AL, that is equation 8. Now put this, means substitute this equation 4 and 8 in equation 1. As you can see here, substituting equation 4 and 8 in equation 1. After substituting, we get the new 2t cos r minus 2t tan r sin I. In second step, we arranged the values. Here we opened the tan r, that is sin r upon cos r. Now here multiply. This step you can see carefully that we are multiplying and dividing by sin r. Multiplying and dividing by sin r. So if you see this structure, we can get the value sin I upon sin r, that is new refractive index. So this value becomes sin I upon sin r new. So this is 2 new t sin r gets multiplied, becomes sin square r upon cos r. Now in another step, we have to take the common out. If we take this common out, and this remains sin square r, as you can see 1 minus sin square r, which will become cos square r, and this cos square r 1 square will cancelled by cos r. Then we get the final formula, that is path difference equals to 2 nu t cos r equals to cos r. Then mark it equation 9. As we know that the ray AB is the reflected ray from a denser medium, so there occur a path difference of lambda 2 or phase difference of pi. So that's why we made some amendments, that means changes in the formula of path difference. So here will be path difference equals to 2 nu t cos r plus minus lambda by 2. Mark it the equation 10. That's it.